My name is Adewale Abati. I'm a staff developer advocate at tbD. Today I'm going to be walking us through a workshop where we are going to be building an example wallet application that consumes tbDEX. We're going to be going through some of the functions and flows that you can implement in your own application. This is not going to be a production grade application, so feel free and make sure that you make necessary changes or security updates as you follow some of the steps in your actual production ready applications. This is only a guide to get you started and also understand tbDEX better. If you have no idea what tbDEX is, then check out tbDEX.io to learn more. Let's get started. Today we're going to be building an example wallet application. The UI is already set up, and we're going to have a couple of mock PFIs also running in the background just so we can simulate the entire flow. This application is built in JavaScript. We have the tbDEX SDKs available in Kotlin and also in Swift, but today we are using the JavaScript SDK. The application is built with Vue and Nuxt, but you don't have to worry about all of those implementations as we are only going to focus mostly on the tbDEX aspect of things. I've also added step-by-step to-dos to the repository itself, so in case you get lost, feel free to pause the video or on your own spare time, just go through the to-dos and the answer key that is made available as well. Now to get started, we're going to clone the repositories that we're going to be working with today, and we have two of them. The first one is the wallet application that is also available at bit.ly/tbDEX-wallet-workshop. The link will be in the description below. This will be our wallet application, and then we also have, let me zoom in on this a bit so you see it clearly. And then we also have the mock PFIs that we're going to be having running in the background, so we don't have to worry about that part. That is also at bit.ly/mock-pfis. All of these links will be in the description below. So the first thing we are going to do is to clone our wallet application. I'm going to copy this and open my terminal. So we have git clone. We're cloning this into the workshop tbDEX wallet. We're not going to do anything with this yet, but we're also going to go ahead and clone the PFI. So we have it here, workshop PFIs. I'm going to copy the link and then also git clone the PFIs into workshop. Yes. So now if you do a ls, which is essentially to list your folders, so you see that we have the PFI folder and we have the wallet project folder. I'm going to cd into the workshop folder for the PFIs and then run npm install. And if that is all good, I'm going to run npm run server. So this is going to set up our PFIs, and we absolutely don't need to do anything again with this particular project. We just leave it running in the background. What it's doing is it's generating deeds for each of our 5 PFIs that we're going to have, that are mocked and running in the background for us to use and work with. So once this is done, as you can see, we have 5 PFIs, 5 dummy PFIs that are running in each of these deeds, and they're running on all of these spots. So the deeds all resolve to localhost using any of these spots to work as an example PFI. And I'm going to open the wallet folder in my code editor. Now, as I mentioned earlier, this is a Nuxt project, a Vue Nuxt project, but you don't have to worry about anything in case you don't use Vue. We're going to be focused mostly on one file, which is the store.js. And if you go through, so for example, you do a to-do search, you will find that we've listed some of the to-do so that everything is easy for you to follow. So this is the only file we're going to be working with. The UI implementation for the application is something that you can choose to build to your own wallet application user experience. So we don't want to focus too much on that. We're just going to focus on things that you essentially need, to have tbDEX running. So this is our application. You can find some of the steps here, and any code that you need to write is also marked with a to-do. For you to start using tbDEX, you need to install a couple of libraries in your application. So most importantly, if you're building a wallet application, you will need tbDEX HTTP client, which is the library for tbDEX itself for you to use on any client-facing project. And then depending on how much implementation you're going into, you will need the Web5 deeds package, and you also need the Web5 credentials package. But you don't have to worry about any of this right now because everything is set up for us to work with in this example wallet application. So what is the first step we need to do? If we go back to our store.js file, we'll find the first to do that is asking us to choose the mock PFI deeds that we want to work with. So ideally in tbDEX, you can find as many PFIs as possible, but based on the offerings that you want to provide in your own application, you can choose which of these PFIs actually match what you want to offer or that you want to get offerings from. It could be 1, it could be 5, it could be 10, whatever your application requires. In this case, I'm going to be deleting 2 of them. This is going to send me to 3 PFIs. So essentially my wallet application is going to be working with 3 PFIs. But in the meantime, we can actually run npm install here as well, and also run npm run dev. So now this is going to enable us to open our example wallet application in the browser. Boom. So this is our example wallet application. I can make it look more like a mobile wallet application as well, so you actually enjoy this. So also here, we don't have much to do in the terminal anymore. We have our application running, and also in our other terminal, we have our PFIs also running as well. So what have we done so far? We have set up our wallet application, our dummy wallet application, and we've also set up our PFIs to be running in the background so that we can work with them. We have selected 3 PFIs, and we're going to proceed to get offerings from each of these PFIs. So I'm just going to ignore all of this part that is, view related code and move on to the next step, which is to do 2. Once you've selected the PFIs that you want to work with, the next step for you is to actually go to each of these PFIs and fetch the offerings that they have available for you, which means essentially you have to look through your PFI list and then call get offerings on each of them. So how do we do this? We call the tbDEX SDK, which await tbDEX HTTP the client dot get offerings, and then we pass the PFI deed to this function. What this does is it makes a request using the tbDEX SDK and then returns into our get offerings. But on our page here, we are not directly requesting for offerings immediately because we have chosen a unique approach to this. What this works is when we click on send money, it's actually then going to fetch all of these offerings and then present to us, or the customer in this case, what offerings are available. In this case, based on the PFIs that we've selected, we have Ghana cedis, South African rand, Euro, USD available for us to make conversions from, right? You can set up this offering flow in whatever way you've chosen. As long as you get the offerings from the PFIs, you can process this data and present it to your customer however you choose to. In some cases, depending on how you have chosen to implement tbDEX, you might not even show this format out to the customer. It could be something that runs in the background where they just select the offerings that you've already have available, and then you process all of this in the background. But this is just one way for you to be able to show offerings or create your user experience for your customer to carry out transactions. So what does an offering look like? We can pick one of the PFIs that we're working with, and I will go to localhost, say 4,000 offerings. And what this does is allow me to scale this a bit. This is what an offering looks like, but this is what offerings look like. When you make a request to a PFI, it returns an array of offerings to you. So this is the first one, which stops somewhere around here. So this is the first offering, and we have a different offering down here. So a PFI might have multiple offerings available for you. So in this case, our offering here is to exchange, Ghanaian cedis for USDC. The payout units per pay unit, which means how many USDC does are you going to get for every Ghanaian cedis, right? All of this information is present in an offering. You can see what PFI is actually providing the offering for you, what date it was created, what kind of paying and payout methods do the PFI require in order for you to be able to actually complete the transaction, and also what required fields do you need to complete this, to be able to process this offering. In this case, the USDC wallet address is required for a transaction that you want to make, changing Ghanaian cedis to USDC. Going back to this, if there's a different flow that you want to implement in your own wallet application, you can do this because the offering is being written as JSON. So when you have all the JSON from all the PFIs that you want to work with, you can process it however you want to. The implementation that we have here is essentially just taking all the from currencies in the offerings and then saying these are the currencies that you can transfer from. So you can choose to you can choose to present this information to your customers in any way that you want. If you proceed with this, let's say we want to do Ghanaian cedis to USDC as the option, as the offering that we checked out, and we get offerings, it's going to display the offerings that we actually have available that match any of these pairings, any of these currency pairings. I'm going to click on Aqua Finance in this case, and you'll notice a redirect that says required credential missing, create credential. So in this case, some PFIs will require you, it is required like in all banking transactions for you to know your customer, or in this case using a KCC, which is a non-customer credential. The non-customer credential is a way for a PFI to know the people that, or the customer that they're interacting with that needs to make that transaction, if they meet regulatory needs for either the country or the currency pairings that they are requesting. So in some cases, a PFI might present to you a widget or ask you to redirect, to a different location, like most of the integrations currently do, for the credential to be able to be created for your customer if they don't have one already. So now we're going to put my name, which is Adewale Abati, and I'm going to put my location and then request the PFI to create a credential for me. Once this is done, I'm back on this field where it shows that my required credentials are now available. What we have done in the background here is send a request to the PFI, like this customer needs a credential that you require. This requirement is also specified in the offering. So if you go to required claims, you would see at the bottom here that the PFI requires that a non-customer credential is passed along with the request if you're trying to get an offering. And in this case, where the customer did not have a non-customer credential, we needed to redirect to make that possible. The actual flow to get a non-customer credential for your customer is actually, has more steps than this. So this is just an example flow to simulate a non-customer credential. The real-life implementation for this might be a little bit more than what we've shown in this example. So for a credential to be issued to a customer, it's essential that the customer also has a decentralized identifier. And in our example application, we do have where we've created a deed for the customer. Right here, initialize deed, we create a deed, a THT deed for the customer. Now that we've created a credential for our customer, this credential is attached to their deed, their decentralized identifier. So you should make sure that you also have that created beforehand. We're going to implement the request for quote, which is the next step after interacting with an offering. So the question might be, why do we need to request for a quote? The offering is only a presentation of what is available from a PFI, and it also comes with multiple information. It comes with different payout methods, different paying methods, and even the exchange rate might have changed. But at the moment that you request for a quote, this quote takes account the payment method that a customer has chosen, if there's any fees attached to this payment method, if anything has changed in the last time that they got the offering and when they are requesting for quotes. And it also specifies an expiry period, like, this quote is going to expire. It could be in 10 minutes, could be in 1 hour, could be in 24 hours, as the case may be. That if the quote is not acted upon in this period of time, then the quote is no longer valid. So the quote is actually making a definite step after the offerings to say, I want to proceed with this transaction. Can I get the more definite one that we can interact with based on what I've selected so far? And for this to work, for us to be able to request for quotes, we also have to prove to the PFI that the customer does in fact have the credentials that are being requested in the required claim section of the offerings. So for us to do this, we need to be able to select the credentials that the customer has on our wallet application and then pass this, the selected credentials to the PFI. This prevents us from just passing forward every credential that the customer might have because they might not be necessary and the PFI might not be requesting them. The process of presenting these credentials to the PFI is known as a presentation exchange, and we're going to be using that from our credentials package to select the credentials that match. And for this to be, we're going to pass the VCGWTs and also the state of customer credentials, which is where we currently store the credentials that we created for the customer. And we also then pass the presentation definition, which is going to be compared to the required claims from the offering, right? So in this case, we are saying these are the credentials that this user has. These are the VCJOTs. This is what the PFI is requiring from the customer. Select the credentials that match these required claims so that we can use them when we create our request for quote. So we are not passing unnecessary credentials over to the PFI. So when this is done, we now want to create our RFQ. And to do this, we are going to run rfq.create. The RFQ is structured with two top level properties, which is the metadata, and the actual data itself. So we start first with the metadata. The metadata in this case would be which user is requesting for this quote. And for us to present that, we're going to be using the state.customerDEED.URI, which is the decentralized identifier string of the customer that is requesting this quote. Next, we'll be specifying what PFI we are actually requesting the quote from, and that will be to, and then offering.metadata.from. If you look at the offering structure, you will see that the offerings that were returned have a from value, which is the deed of the PFI that we're working with. So that is what we're passing to the metadata for the RFQ that we're creating. And the next thing we also need to add will be protocol. Protocol in this case allows us to specify what version of tbDEX we are using just to future-proof stuff, and for any message interaction going on, for you to know what tbDEX versions or data that is required to actually complete this transaction in case more tbDEX versions come out in the future, because right now it's at tbDEX 1.0, so we specify 1.0 for this value. And that's it for our metadata. The next thing we'll go to now is the actual data that is going to be passed along for this RFQ. And the first thing we want to pass is the offering ID. So we are selecting this offering, and we get this from the offering itself as well, offering.id. And this allows the PFI to know what offering we're talking about. Now we want to tell the PFI this is the paying methods that we've selected. This is the data about the paying methods that we've selected. The first thing is amount. How much do we want to actually exchange? We need to make sure that this value is actually a string. So ensure that you do to string here, or maybe somewhere else along in your code. And then we pass the payment method, the kind of payment method that we have chosen. And in the context of this example, we've only selected or provided one paying method for each of the offerings. So I'm just going to keep it simple and just do offering.data.paying.methods and just select, the first index dot kind, exactly, which is what I'm getting from this value here, for example. Normally, you would have a view in your wallet application that allows you to click on whatever payment method is available. Do they want to pay with card? Do they want to pay from the stored balance of your wallet application and stuff like that? But this is an example application to help you, understand the flow. So the next thing we're also going to be passing now is the payment details. So this is where you would pass for example, if there isn't paying with card, you pass the card information and all of those things. But in this case, we're not passing anything as an example. But in this case, we're not going to be passing anything just for the context of this application. And that's it for paying. Now we need to specify how and where we want to pay out to. So for payouts, we don't need to specify amount because amount has already been specified in the paying, and then the paying payouts units is what's going to be used along with any other fees. Paying payout units per paying unit is what's going to be used to get how much or what amount is actually going to be sent to the recipient. So in this case, all we need to just specify is the kind. This is how the person is going to receive the money that we've chosen, which could be bank account, it could be USDC wallet address, it could be any of the options that's specified in the offering itself. So we're going with offering the data, the payout methods, the first one, which is the only one. And now we actually pass the payout payment details, which includes the USDC wallet address from our form. So if you're wondering where we're getting some of this value, we have a create exchange function here. And this function has been passed offering, amount, payout, payment details. It's how you would do every other form where once you click submit, you take this information and pass it to a function. But we don't want to get into too much, non-tbDEX related stuff, because that's however you choose to implement your form is up to you. But once you get that data, you pass it to a function, and then you pass the actual data into wherever you need to put it, which in this case is creating an RFQ. So once this is done, we have actually completed the first step of our application, which is to create an RFQ message. So once we've created our RFQ, we need to make sure that the RFQ that we have actually created matches the requirements of the offering. So we ensure that no mistakes actually are put along the flow of moving data from the form to our function and all of those things, right? Just to be sure. So what we're going to do here is run await RFQ dot verify offering requirements, and then we pass the offering into it. This is a function that returns void, but it throws an error if the RFQ does not match the offering, and that error is what we're going to catch with our try and catch. But if you run into an error, you can catch this error however you choose in your application. It could be that the user provided wrong information, or you did not do some validations correctly. So you can take them back a step, or just implement however you choose to. So that is it for our fifth to do, our fifth step. Once the RFQ is verified that it matches the offering, we then have to sign the RFQ message. How does this work? Signing the RFQ message is a way for the customer to indeed put their stamp on it, to cryptographically sign the message that, yes, I as the customer am making this request for this quote. So to do this, we're going to await RFQ, which is what we just created, a sign, and then we pass the state that customer did to it. Now, if you've paid attention so far, you'll notice that for the metadata, when we're creating the RFQ, we specify the from, but we only use the URI, which is just the string for the customer's deed. But in this case, because we want to sign, we use not just the URI, but actually the bearer deed, which is the deed we keys to be able to sign this message. And then we can log our RFQ to the console. And then our final step for creating an RFQ would then be to pass this exchange, to send this RFQ to the PFI while we wait for the next step. So to do this, we're going to await and call tbDEX, tbDEX to client, create exchange, the RFQ. Now what this has done is we've taken our RFQ, we've verified that it matches the offering that we've created, we've signed the message, the RFQ message, that yes, this is coming from the right customer, and then we pass it to the PFI for them to work with and then send us back a quote. So we've completed this flow, a flow to request for quote here. So I'm going to go back to the UI to show you what that looks like. Now I'm going to request for quote, and boom. As you can see here, it says claims do not fulfill the offering's requirements. So I made a mistake here where I needed to also pass the claims. So now we need to pass the selected credentials as part of the claims for the RFQ. And for this, we're going to pass selected credentials. Once this is done, now we've basically gone through the flow. We've selected the credentials that match the required claims of the PFI for that specific offering. We've created our RFQ here. We've verified that our RFQ does in fact match the requirements of the offering. And now we've signed the RFQ with the customer deed to also authenticate and authorize sending the message to the PFI, confirming that this is in fact from the customer. And then we send the message. Await tbDEX client.create exchange RFQ. Requesting for quotes. It's loading, and boom. If you look at this, we've gone through all the steps. This is the RFQ that we've created. We have the offering ID. We have the claims which is the credentials, which has also been encrypted before sending it out to the PFI, and also the payout information is also encrypted. Everything before being sent out, the paying and payout information are encrypted before being sent out to the PFI. That is all done with the tbDEX SDK. So now we've gone through the flow. We've gotten offerings from the PFIs. We've been able to, request for a quote. So how do we know when a quote is available, right? So that's the next step for us which is to do 8, which is to get exchanges from the PFI. Since we are building a client-facing wallet application, there's a high chance that the wallet application will not have a server that could, receive a callback or serve as a webhook to be able to update exchanges. So in this case, we're going to request exchanges directly by pulling the PFIs that we have on our list. So what we're going to do here is to use the tbDEX SDK again. So await tbDEX HTTP client or get exchanges. And then in this case, we want to get exchanges from a particular PFI belonging to a particular user. So we're going to pass PFI deed URI, and then we're going to also pass the customer deed, which in this case is our state of customer deed. So what this does for us is it allows us to be able to reach out to the PFI using the PFI URI specified, and also authorize that, yes, I want to get exchanges for this particular user using their bearer deed. So we've done a lot of other UI stuff to properly format the messages, but if you go back to our UI and we refresh, we should be able to get the exchanges that we've made so far. Yes, so we quoted 400 Ghana cedis a couple of seconds ago, and you can see the information here, the recipient details, we're sending it from you, the amount you're trying to send, and the date that the quote expires. But what is inside a quote? I'm going to show us real quick what's inside a quote by coming to line 203 and just commenting it out and then refreshing, just so you can see what is in the quote. So a quote in this case, which is what we get after requesting for quote, takes into consideration the payment method that we've chosen, if there are any fees, and you can see in the data here, it includes when the quote expires, the amount the customer is paying in, and also the amount that are going to be paid out, and also the valid next steps. If you look at in this case, when you've received the quote, you can either place an order, which is like sending an order message, or you close the transaction, probably because you don't want to proceed with the quote. So that is also an option that is available for you. So we're going to go back to our code now to implement what happens after we, get a quote back. For us to consistently get any new messages from the PFI, we also have to pull the PFI regularly to be able to fetch exchanges from the PFI. To give you context on how this is done, I have a pull exchanges function in this wallet application that you can check out. And what it does essentially is after every 5 seconds, it makes a request by looping through each of the PFIs and then fetching exchanges, which is a function that we have up here to get exchanges from each PFI. So after every 5 seconds, it makes a request. Are there any new messages for me? Are there any new messages for me? And with this, you are able to get any updated message. If a quote is available, if there's an updated message about the transaction, the order status of the transaction, you are able to get all of this from your wallet application, even without a server. So now that this is done, we're going to go back to our next step, which is to do 9, which is essentially creating a closed message. A closed message comes into play at different times in the tbDEX workflow. It could be when the customer doesn't want to proceed with the quote, or when you've actually proceeded with the quote and the PFI is saying, okay, we're done with this interaction, I want to close this message, or the user wants to close the message at any point. That is when you send a closed message. It essentially ends the exchange. For us to do that, we're going to use close.create. And this one also has 2 major properties that you need to pass, which is metadata and data for it. So we're going to pass the metadata in this case. Once again, it includes what customer wants to close the message, and also to what PFI. This is also passed in the function. One thing that is also new in this case is we will need to specify the exchange ID, because now if the user is already interacting with the PFI, they could have multiple exchanges. So we need to say we want to send a closed message, but from what customer to what PFI, and talking about what exchange. So that's the exchange ID. And we also specify the protocol, like I explained earlier. In this case, it's going to be 1.0. So that is all for it for our metadata. The next thing will be for us to specify data. And in this case, if you're sending a closed message to an exchange, you want to specify a reason. From the wallet, and you need to specify why you're canceling this message. It could be because the user canceled. It could be for whatever. Probably maybe insufficient balance. It could be anything, right? So we specify the reason, which is already passed from the function, the add close function from our UI. So once this is done, Following the previous steps, we have to actually sign, like I said, create the close message, sign it, and then submit it to the PFI. So in this case, we're going to come down here and do await close the sign, and then we pass the customer ID as well. Now we're going to also send the close message to the PFI, but in this case, it's going to be await tbDEX. I have GitHub Copilot on, so don't worry about that. The HTTP client dot submit close, and then we pass the close message to it. This completes our close message. Once we do this, it's going to send a close message for that exchange ID to the PFI, and the transaction ends at that point. If the user doesn't want to close here, the alternative is to, add the order, place an order. And when you want to place an order, all you actually need is just the metadata, because you're already saying yes to the code that you received. So once you're saying yes to the code, in this case, we're going to use order.create. And then we specify the metadata again, just like all the other functions that we've created so far. Everything follows the same developer experience, trying to be as intuitive as possible. So if you come across any issues, you'll to most likely follow the same structure like any related function has been. The same way we've had rfq.create, close.create, order.create in this case, metadata, data. So in this case, our metadata again will be from the customer, which is state.customer did the URI to what PFI. We also pass the exchange ID, and then we specify the protocol as well. So once this is done, we also have to sign the message as all other messages. So await order.sign. You can also choose to put this in a try catch, whatever goes with you. And then once that is done, we submit an order. Await tbDEX HTTP client, submit order, and then we pass the order to it. So this takes what we've created. As you can see, the major difference with order.create is we're not specifying a reason, because you don't need a reason to complete the transaction. We're not specifying additional data because we've provided the data with the RFQ. So we just click on pay, creates the message, and it sends it to the PFI. Yeah, so now we've implemented close an order. We're going to test it. I already have one transaction here, so I'm going to create another one real quick so that we can test both close and order for the transactions. We select Ghana cities, select USDC. I could do something like, say, 600 in this case. Oh, sorry. 600 in this case, specify the wallet address, and then request for quote. That's creating our RFQ, and then when it's done, it takes us back, sending the RFQ to the PFI, and then once that is done, it goes back to the home page. This is taking a bit long. It could be because the servers are slow or my internet is slow. So now we have two transactions. I'm going to take the first one and cancel it. And it should send a close message to the PFI because we are canceling an exchange. So now that we've canceled the message, if you look at any of our return exchanges, for example, this guy, would see that the status is canceled, which basically updated our message as well on our UI to show that the message is canceled. Our close message is working, and the next thing we want to try out now is to pay 400 Ghana cedis and see what that happens as well. So once we click on pay and we send an order message to the PFI essentially, receives the message and starts to process it. So not everything might be instant, so it might not get sent immediately. But because we continuously pull the PFI, we get to see different update statuses that are being sent back from the PFI. So it could be, payment is being transferred. It could be any other status messages that is being sent from the PFI and that we are pulling to see the updated message. In this case, the PFI has updated us that the order has been completed and our message here has changed to 400 that we've sent 400 Ghana cedis. So here we have the cancelled transaction, the cancelled exchange that was ended with a close message, and we have one that was ended with, the order message. This is essentially us going through the complete flow of building an example wallet application with tbDEX. We've been able to get offerings from the selected PFIs in our network, we've been able to request, select an offering and then request for a quote from them, and then work and then interact with that quote to either close it or place an order on the quote. And that brings us to the end of today's tutorial. If you run into any issues, if it's running a bit too slow for you, if you run into any issues or have any questions or I probably made a mistake somewhere along the line that could have been confusing, find out you can join our Discord. That's discord.gg/tbd. The link will also be in the description, and we'll be excited to assist you and make it easy for you to build your next application. Thank you for making it to the end, and we'll see you in the next video.